Okay, so hi everyone. We're going to start right about now. So, welcome to our workshop, Coding the Unshareable. I know it was called Breaking and Hardening the Cloud before, but we just refocused so that people knew what they were getting into. We're not going to like dump secrets of AWS bucket. We're going to do assembly and a lot of assembly. So, yeah, just that's the reason why we changed the name. So I already said it, but just saying it again since in case someone joined recently, um, you need to send to Flightbot on the NorthSec Discord server the workshop 1443 string that you see right there. This will give you access to the workshop content, especially the Git that contains the all the exploits and boilerplate files. And also, if you want to follow along with access to an infrastructure, please send to Ashley the email of at least two people, their Google account, so we can give you access to one instance. So, first thing first, for any talk or workshop or anything, just presenting yourself. So, my name is Philip Dugray, or 0x64 on the internet generally. I work as a DevSecOps at Pivotal Technologies, and I've been a challenge designer at NorthSec. It's my 6th year this year. Some of you, if you do the CTF, may know me as the Rust guy, and you probably hate me too. So there's that. Ashley, want to present yourself?
Yeah. Um, Former pen tester, then code reviewer, then infrastructure reviewer, then protocol reviewer, and then set up the team of Pivotal specialized in digital transformation. If you guys can hear me, yeah. And we've been doing, while doing transformation, we realized if you want to do it securely and manage operations in a way it's handleable by other groups, we started doing our own platform engineering. And the platform engineering to become more approachable needed its own agents to simplify the setup flow and GitOps flow in particular. So that's why we started InfoStream around 2 years ago. And so the solution is currently being hosted in the beta version of InfoStream. And that's why we wanted to show how if you do things in a InfoStream manner in GCP, you get a lot of security features out of the box and a lot of configurability instead of having to do it yourself in GCP. So that's my part. And I'm going to be doing the hardening part of this workshop.
Yeah, if that was not clear enough, I'm doing the offensive side. So, like I said, a lot of assembly. This is a slide that just says the required tool. Yes, you need a laptop to write assembly, you know. Since we're developing a Linux exploit, you need to be able to build and test on a Linux machine. It can be native or VM, I don't care. You will need basic things to compile code, so like Git, GDB to debug, especially because it's assembly, code editor, that stuff. For the programming language, uh, I'm going to provide to you a bunch of, one Python script that does a part of the exploit process, but yeah, just that we've been cut a bit of time, so we skipped that part. But yeah, we'll give you the first part of the workshop, not really working Python script. So you need Python. You don't need the Go compiler. I don't know why it's still there. And yeah, if you want to use the exploits and the boilerplate I already made for you guys, you need the Rust compiler because I'm a big Rust guy. But yeah, since it's process hooking, what you really need is a compile language that has kind of easy access to doing like disgusting things like pointer arithmetics and stuff like that. So something like Rust, Go, or C is all right. It's just that I'm more used to Rust. You need some reverse engineering software. Gonna use Gira this time. And yeah, that's it for the tools. So now, what is this workshop about? Basically, like Ashley mentioned, we're working at Pivotal where we develop InfoStream as part of our offerings. And InfoStream, the like very big picture for people that don't know much about platform engineering is like a self-hosted platform as a service. So you have everything is as code. You just write your manifest file, commit it on GitHub, and it will like do all your infrastructure for you. And then you can focus on just writing code for your deployment. Basically, what I wanted to do was an exercise where I would create a smallish application. You'll see it a bit later with vulnerability and basically, I wanted to get an RCE, a reverse shell, like an attacker on a naive deployment. So let's say just deploying it on DigitalOcean and calling it a day, and mostly default with a default infrastructure setup. And we wanted to see that to see what potential default hardening we could add to our deployment, and also for a bunch of blog posts and stuff like that. It's almost some R&D in some aspects. So yeah, that's what we did. We're going to deploy an application, break it, and harden it after. I think that's you.
Mm, Give me 1 second. So I'm just gonna share what in order to get access on the Zoom. Um, oh, I'm currently approving using InfoStream all the tooling and all the questions that you guys did. It's automatically generating all the pull requests and getting the validation from some of the emails. Sorry, I leaked I think one email. The rest of the tooling, after I approve and get InfoStream running, you guys will be all assigned in different uh, so I'm gonna re-add you guys so that at least I think 7 of you guys can join the different teams, and then
Hello? I'm just gonna say it in the mic so that everybody can hear. Basically, we will whitelist your Gmail account on your specific instance using Google Identity Platform, Identity Aware Proxy, so IAP. So from there, you will just be able to be on the website, log into your Google account, and just access the app through there. Oh, yeah. Yeah. But yeah. Yeah. So the URLs you'll have access to. Ashley is going to put them on Discord. But basically they're the portal app for the infrastructure for InfraStream that will allow you to see deployments and everything. That's more for the defensive aspect later on. There will be two GitHub repos or three. On peut tout manifeste, les participants? Ok, mais ils vont pas avoir besoin d'avoir accès au repo de manifeste, pas grand-chose. Non, c'est juste. Ok. Okay, so yeah, there will be that. There will be the GitHub link for your specific team to be able to view and modify the code. Again, it's mostly for the defensive aspect after it. And you will have access to the app with the last one. So app.team dash, let's say, 3 dot all that thing. But it will all be posted on Discord. Don't worry about that. Yeah. It's workshop 1443. It's on the screen right now if you want to double check. Okay. Okay. So what we're going to do right now is that the vulnerability is actually pretty basic and also very synthetic. But basically, it's a bash injection vulnerability that you can exploit from a template injection vulnerability in Go. I'll show you later, but basically you have a review service, and the way templating works, you can call like a hidden function that's checked into a file to replace with like product specific items, basically. And you can use that to do a bash injection. So it's a pretty easy way to achieve RT. But like I said, the fun part was more trying to evaluate the level of pain. So the goal was really to get a shell from there. So there's that part. Building RWX gadget. This part has been kind of scrapped over because of time. But I will do pass on it technically, just explaining what it does. But I will give you a Python script that will allow you to go to there to upload, download files, and easily execute code from there. Another thing that's been kind of scrapped, we used to do it on Scratch container that do not have like anything on them. So initially you had to build statically the core util. So if you wanted to use, let's say, the basics for command, you had to build it statically and upload it yourself. We scratch that part. I'll still probably go over it like just speaking, but you won't have to do it actually. From there, you will download the server binary, reverse engineer it. Not really reversing, but trying to find good injection point for the backdoor after. After, we'll write a backdoor on one HTTP handler so that when you get a review that starts with a specific string of character, a part of the ID, we'll detect that and give you a shell instead. And yeah, because of network restriction, we'll also dive into how to do a socket reuse shellcode, because network restriction disallow egress, so you cannot do either a bind shell or a reverse shell. So socket reuse is the only thing you can really do. For the defensive part, I'll leave Ashley to it.
So the defensive part is just going to show how InfraStream can address route level and the architecture for routing internally to the resources of InfraStream, and an external egress, the runtime, how we manage CI and how we manage deployment to InfraStream. But it's also an introduction on how to do things securely for deployment in GCP. But DevSecOps, kind of a pattern we use at scale within the solution, just to show how difficult things can be if you configure themselves if you configure them yourself versus InfoStream, and how we manage the egress and how we manage the different types of authentication to have every external endpoint be authenticated before routing to your cloud resources.
Thank you. Okay, so yeah, that's a bit of technical detail. I think I'll put the slides on the repo after, but yeah, that's just technical explanation of the vulnerability. We'll go over it real quick, but yeah, template injection in Go. I use it to call a custom function that calls a bash underneath, and I do an injection in the bash. So that proof of concept executes who am I. When you write a review for a product on the app, you input that, and when you read it, that will just return to you root, basically, because it will replace that string with the content of the comment. Like I said, a big part of the workshop is just that the hardening made it a lot more painful than it would be otherwise. So the relevant hardening that was yeah, that was an issue. The first one is that it's behind a NAT, load balancer, all that good stuff. So inbound access, it's a web server, it's a web app. So the only thing you can reach is port 443 for HTTPS. So like I said, that disallows bind shells, which is pretty standard at that point. Nobody uses bind shell anymore. But what's less common is that there is no egress network access. So the app cannot ping the internet. And if it can, it's a whitelist. So you cannot just use a reverse shell, host your own handler on the internet, and ask the server to connect back to you. You cannot do that. So that's the part that where the socket reuse comes in later. Apart from that, like I said, we used to use a scratch container, but we scratched that. Ha ha ha. We scratched that because like it's not a 3-day training. So there's that. And yeah, we disable a few feature again just for to make the workshop easier. Normally we run in serverless so like the instance spin up for like a few minutes and then just die, and like for developing an exploit that's just a pain because you have to redo everything again every 10 minutes. So we disable that. And also we generally have auto scaling, and we also disable that and give you only one machine each. And that's because if you will send multiple requests, you want to keep the same state between them. So if I upload a file and I try to execute it, and the execute command runs on another machine because of the load balancing, well, it won't work. So we limit it to one, so you're always working on the same like actual server behind. Yeah. The first part, that's the part that I say that I will be going around kind of quick. But basically, we can do a built-in bash command from the website itself. I'll try to show the website after. That might be a good idea. But yeah, you can execute built-in shell command pretty easily. But when it comes to you cannot post a review on the product that spans over 5 million characters. The web server will not like that. So you need to chunk your upload. You need to make sure you're able to upload and download binary files, not just text files. So the goal of the toolkit I'm talking about is just to be able to write a simple-ish script that allows you to upload, download without having to do it everything manually every time. Just works, and from there you can move on to other stuff. Yeah, again, that's just a bit of escaping we have to do. We'll skip over that. And yeah, we also do a cleanup after that, so we delete the review right to make sure it doesn't trigger every time see it. So, like I said, this section I'm gonna go pretty quick because like time cuts. yeah, that's pretty much what I was saying. Where you normally we were doing it on Scratch. So on Scratch, you had to write a using printf, which is actual built-in and not binary on your system. So you would do that really interesting bash snippet to basically that's a next decoder in pure bash. It's really slow, it's bad. So what I would do from there is to use it to upload a very small base64 binary that I wrote. It's in the repo and everything. And then I would do a third stage where I use that base64 executable to upload the actual fat base64 executable you're normally using and other like commons that you need to do the rest of the exploit. One of the big reason I use Go for my exploits is that you know that line right there, that's static compilation and it just works. That's great for a thing like that. So static compilation, for those who don't know too much about it, static compilation means that your executable, everything is packaged into it. It doesn't rely on other libraries that are outside of the binary itself. So technically, and that's what a scratch container is, you can have one file in your file system and it works, the executable itself. Yeah, that's the three stage I was mentioning earlier. File chunking, you cannot send a 4 million character review, so you need to send it in chunks. Again, that's all in the script that's going to be provided to you. That's just a proof of concept that this specific shell, you can actually build it statically. So even if in a Scratch container, you can upload that shell and get your interactive shell in it, even if your container does not have any shell. So that's cool. Network. Okay, yeah, we're getting into technicals very soon, I promise. So actually, let's do it right now. Just give me a minute. I need to know which instance I can break. Found it's pretty useful when you want to talk. Yeah, so that's the app I was talking about. It's vibe coded. It's a iSlop, so it's app broken, but we don't really care. It's for a demo. So that's the page where you can like check a bunch of products and order them. The order doesn't work because I don't care. And when you go into it, that's where you have a bunch of reviews into it. If I go over there, oh yeah, sorry, IDPI. Okay. So I can leave a review. So I can say, hey, I don't care if it's broken. Can submit a review. That's cool. Now, if I go back to the slides, I do have. I click not on the text box. Just going back to the proof of concept. So if I take that and I post that as the text in the review, when it'll get rendered, that's a very good proof of concept. Oh, I think it's an escaping issue. That's great. Yeah, that looks like a small copy paste issue, but moi seul de l'injection. Always be prepared for your workshops. Uh, yeah, I think that works. It just doesn't actually return to me a value, which is kind of a pain. But yeah, either way, like I said, it's already pretty automated. So even if that doesn't work, it just sucks for the demo. But yeah, basically a command UMI runs. I just don't get an output because I forgot how. That's it. And yeah, that's it. We've got simple code injection from there. So if you go into the repo, the NorthSec Workshop 2026, you will see that there is, yeah. Okay. I do have a lot of stuff in the README that explain what everything is, but what's relevant right now is the gadget.py binary. So once you set up virtual environment, like I said, that's all in the README. You can just call it. That's not what I wanted to do. But yeah, gadget, the PI. I just need to change because I was not staying on the same thing. CO2. That's a weird one. But yeah, just explaining the arguments real quick. You need to specify like where to send it. Then you need to specify a product ID because if you recall, we're writing a review. So the UID in the URL is the ID of the product. So we need to specify which product to leave a review. So that's that part. And then you can, I have multiple commands, most notably upload, download, and execute. Execute executes a command. And 302, what's that HTTP code? I never remember. Redirects it. Yeah, another thing is that when you go, like I said, we're using Google IAP. So this is all authenticated using my account. So I do have something. Where is it? Please. Yeah, I do have a file that's called token, and from there I just dump the actual cookie that I can steal from my browser. So yeah, from there, just so you can see a bit more clearly. Yeah, I'm just going in storage, cookies. I I don't know which one is it. Why do I have to delete everything? Yeah, it asks me to reconnect. So yeah, basically you can create a this file, the .out token, which is referenced in the code itself, and can just dump your token from there. And why am I using them right now? It's not very efficient. Yeah, it's the access token. Like I said, when we said we wanted your email, it's so that you can go through Google Identity or proxy. So that's the token that you're using to access the app. Okay, now it actually works. That's great. So here, as you can see, I use the execute command of the gadget script that exploits the old vulnerability I talked about earlier, and it returns to me root. If I go ahead and I use ls to read, I already know where the binary is, so there's not much, but I know it's in the root directory, so I can execute the ls command and see that the binary is right there. You may need to search a bit, but it's right there. So yeah, for the backdoor, since we cannot do a bind or a reverse shell, the only way to communicate with the process is through the connection you already have when you ping it via HTTP. So the only way to have access to that is to actually be in the process itself. So one thing to note is that this is running in a Docker environment, and if you already try to kill the main process of a Docker container, yeah. If you try to kill the main process of a Docker container, the container will just restart itself. It's PID1. It's the same thing if you kill it on in Linux. Don't do that. But what that means is that yeah, the socket for the HTTP, like the only allowed port you can use, is already in use by the process. You cannot kill a process, and you cannot replace the process, because if you do, you'll have to yeah, if you do that, you'd have to kill it to restart it, and like I said, it will restart everything. One last thing is that there are also health checks. So even if you replace the entire process itself, the health check will kill it afterwards. So you want to keep the process alive, the service alive, and what you really want, if you want to get like interactive shell, is to hijack it, inject into it, put a backdoor. So that's where we're going to do a little bit of a low level coding. The first thing is that we're going to download that file. So, like I said, I got a few comments in my script. So, if I recall correctly, it's download, then it's the file I want to download in the file system. So, dash root dash sandbox svc review, and then where I want to put it. So, I'll just call it server. Then you'll see it will do the bash injection a bunch of time and just download it over. This can take a minute. I promise I will leave you time to do it, like, soonish. I just want to get, like, the basics started, and then I'll dump you in the, I'll drop you in the, forgot the name, the template, the skeleton exploit. Okay, so now that the file is downloaded, I documented how to start it without it crashing on the repo. So it's like something like that. I need to make it executable. It's something like that. So yeah, like I said, the environment variables and everything is documented in the README of the repo. But basically, from there, you're able to host the service on your own PC, so you're able to debug it and whatnot, and develop your exploit. So just return to the slide a bit, see where we are. Yeah, that doesn't really matter. Okay. Well, actually, I'll just leave you like, let's say 15 minutes just to get set up and everything and get to that point before I continue because yeah, next part is gonna be a bit harder. So yeah, slides incoming. We're just duplicating it so you have a view for it. But yeah, kind of forget about that. It's pretty useful. Yeah, perfect. Yeah, for those with trouble with the hot token files, it's in the get ignore. So if you check in the get ignore, you'll get the exact name you need. And basically, what you want is to go on the app from your browser, go into your cookies, and paste basically the two values that are the host GCP IAP hot token. And I think you need GCP. Well, you don't even need that. So for you just need to put like name equal value in the file, and that should work technically. And both Python scripts rely on the presence of this file. Also, just mentioning that you can feel very free to ask questions. That's why it's a workshop and not like a talk. I can come and help if there's anything. For those having trouble with the access, just make sure that you send the emails to him and not to me. I know I received a couple of messages, so that might explain because I'm not looking at them. So yeah, just make sure. What's your Discord username, Ashley? Prom? Okay. So yeah, send it to Prom. Okay, I know that you guys are like kind of spread out for where you are right now in the workshop, but I'll move ahead just in the interest of having time to do everything. So yeah, once you get the server, now we get into the, let's say, binary analysis part of the workshop. We want to backdoor it, so we need to get a few information about it. So first, I run the file command. I don't know if you can see well, but if you run the file command, you're able to see that it's statically linked Go executable. So that's not stripped with debug info. That's cool, so it's easier to reverse. And statically linked, like I said earlier, it means it's not relying on anything external. And what's really cool in the context of a backdoor or something like that is that the binary is large. So you got a lot of space to work with when trying to write your own code. Next thing to check is the classic checksec script to see the like security features that are enabled on the binary. And what you'll see pretty quick, which is really cool, is that there is no PI. PI stands for Position Independent Executable. And what that means, if you know what ASLR is, ASLR is what makes it so that each time you run a process, the address are different, which is meant to for exploitation. But if you don't have PI, all the actual process code, the executable code, the code that comes from the binary will always be loaded at the same place. So in that specific case we have here, the all since it's statically linked and there's no PI, all the libraries used are loaded at the same place. All the code that's written are written at the same place. All the constants are written at the same place. Global variables too. What will be randomized is the stack and the heap. But that's very cool because we don't have to be do pointer arithmetics for backdoor, since the place we're going to inject is simply not randomized because of that. So that's great. And next thing I wanted to point out, you do have access, I think, to the application code of the service itself. It's NorthSec Sandbox SVC review dash 13 number. And if you look into it and you're trying to find a point of injection, because like I said, we've got symbols, so it's kind of easy to map it to assembler. In the handlers.go, you can find the perfect candidate, which is a get review. I just want to make it clear that um, the review service is a microservice that only handles the review. So you need to put your backdoor in an API that's related to review. I like get review because you can, this one takes an ID when you get a review. So you can use that to decide if you trigger the backdoor or not. And also because it's a get request, so it's like a non-destructive operation. It doesn't change anything to the server. So if you look at those 3 lines of code right at the beginning of review, I take the ID, never too much zoom. So if you look at the first 3 line of the get review HTTP handler, you can see that it takes the ID of the review itself and it does a printf, so it can then go into Redis to try to see if it's cached anywhere. But the important part here is just that at this specific point in memory, which is like very specifically right before the printf, you do have a register that points to the ID. So if we inject at that point specifically, we have access to the ID, which we can control when you're trying to trigger the backdoor afterwards. So if you look into Ghidra, this I oh yeah, I can zoom in. If you look into Ghidra and you search for get review with no S, just get review, Get review. Okay. If you move into this and you look a bit around, you'll see that, like I said, we want to inject basically right before the sprintf. So I'm just looking to see where is the call to sprintf. Which is right there. So this line is this line. And since it takes as argument the ID, we know we can get the ID from there. It's just need to recall where it's located. Yeah, if you check the flow a bit, once you do the convert to string, I actually don't remember. Let me look at my code very quick. Okay, it's pointed to by RDX. I did that with like debugging and everything, but like I said, we don't necessarily have all day to do it live. But yeah, when you get to that point in the RDX register, you have the ID. So I want to inject around that. One thing to note, if you just try to hook on, let's say you try to hook on that, you'll get problems later on. The reason is that when you're hooking, if you don't want to make the operation destructive, at the end of your shellcode, you need to do the instructions that you've overridden. The problem here is that this is a Go function, and the Go runtime do have what we call control flow guard, or at least some version of it. So that means that everywhere where in the code where it's normal to return to is registered, and if you try to return from a function, from a Go function, and it's not registered, it will crash. If you call this Go function from your injection, this is not registered, it will crash. So make sure you don't override that one. So the exact spot, if I recall correctly, that I choose when doing it. It's RC. Yeah, where I decided to do the injection when I did the exploit was especially right here. So yeah, from there I just note that address, which I have to zoom out a bit because it's out of frame. So I can take that address and in my code I can go put it over right here. Now I just realized I kind of skipped over the boilerplate, so I'll go do that right now. Okay. So when you go into the repo, the injector is the part we're doing right now. It's the binary that injects the backdoor into the process we want to backdoor. So injector specifically is the completed exploit. This is supposed to just work when you run it. What I also gave to you is the injector boilerplate, which is just a very stripped down version of it, so you can start working on it right away. So here I would put bub constant, the address where I want to inject the hook, and I would paste that address. So that's the first address we need to do. Now, when you're doing hooking, you don't want to just go ahead and override the old function it's kind of painful to recover from that afterwards. So what you want to do is that you want to go ahead and just do a very small shellcode that you inject over there that simply jumps somewhere else. So this, when you compile that, that's like something. If I recall, it's like 7 bytes, something like that. So that's pretty small compared to the whole payload that comes after. So what I want to say with that is that the payload itself, you want to write it somewhere else where it will not break everything. Normally, we use something that's called a code cake for that. There are a lot of software to look for them, and those are just regions of memory that, because of padding and structure alignment, ends up being empty or just trash data. But when I did the analysis, sorry, English not great, analysis of the binary, I couldn't find one big enough. But what I did found that was pretty interesting is that there is a bunch of FIPS 140 forgot the name function. So just a bit of context. FIPS 140 is a standard from the U.S. government, from the NSA, basically, that tells you what that tells you what algorithm and especially what implementation you can use for cryptography on U.S. government computer. Because it's done by the NSA and because everything in it is so outdated, nobody uses that except the U.S. government because they have to, for a lot of good reason. But the point is that you have a setting at the OS level that tells the go runtime, am I running in FIPS compliance mode? And based on that, the Go binary will dynamically choose between the FIPS version and the non-FIPS versions. So what I mean by that is that's all garbage that you're never going to use because you're not running on FIPS. So that's a good place to inject a bunch of stuff. Especially right now, there's just a bunch of zero. And right after, you're doing the parsing of raw data in ECDSA. And yeah, that's never going to get used by that process. So you can just go ahead, take some place, and an address that's aligned. So when I mean aligned, by the way, is that pointers in 64 bits. Um, when I say a pointer are 8 bytes long, so you want basically an address that modulo 8 gives 0. You want it to be and with either 0 or 8. So that's a valid address. That's a valid address. So I'll take this one just because I can. So that's another address you can save for later. Yeah. So basically, if I go back to the exploit, what I want to do is I want the hook. Uh, yeah, this is just because I cannot jump to a 64-byte address. So that's just a bit of like assembly workaround. The push RAX is there just because I'm going. Sure, I could have put it. Oh yeah, it's because I want my shell code to my hook to save and restore all the relevant registers so that the process can continue after the hook without crashing. Since I'm overriding REX right here, in the hook, I push it first. Then, like I said, I'm putting the address of where I will put that payload. And when I jump, I will jump to the FIPS function, which after the process injection will be overridden by all that good stuff. And then, like I say, I just push a bunch of register. This is also assembly that just checks for the backdoor. This, I'll come back later, but it's like diving into the Go structure to find the file descriptor of the connection. Then I fork the process. The parents return like nothing happens, and the child, yeah, the child process will use the file descriptor we found earlier, which is the current HTTP connection, and bind to std and std out std error and execute BNSH. So that's basically how you do a reverse shell normally. It's just that instead of uh, creating your own socket, you take one that already exists because it's a web server, so you have a connection somewhere. Then, yeah, bit of like cleanup. Like I said earlier, you want to redo the instruction that you've overridden if you don't want everything to break, and you jump back to right after the hook in the code. So, yeah, I'm trying to go a bit fast just because time is running a bit short. But yeah, that's the gist of the shellcode itself. And yeah, basically there's two injection. You inject a small hook in the handler that jumps to the unused fifth function, and in that one you inject your big backdoor itself. So yeah, that's it for the shellcode itself. I'll go right over to the technical parts that's also really relevant right after. It's the injection methods. So, yeah, that part, I did that part, I did that part. Yeah, I do have a section about like things that are specific with Go, so I'll just say them as they come, but I won't spend too much time with that. There are three main methods to inject into the memory of a process. I have to say that's already running. That's a big distinction. The first one I did, and I think it's a good like all-around solution, is using ptrace system calls. So ptrace is the API that the kernel uses to allow debugger to stop, modify, uh, basically debug to debug an application, and those comes with write access because the way, mostly because the way breakpoint works in a debugger, the debugger have to write in the process memory of the debug process. So that's the API that the debugger uses for that. The next one is that you might have heard the saying that in Linux, everything is a file. So if you go at /proc/ the PID of your process /memory, just mem, and you just open it as a file, well, you can read and write to it, which is pretty funny. I gotta say that those works specifically because you're running as root and because you have the ptrace capabilities. That's something we'll see with the hardening that can all be blocked. The third one is in red because it's quite a lot harder to do. But there is an actual system call, you can call the Linux kernel, that allows you to read and write the memory of a process, which I don't recall exactly what, but it's a bit more permissive in the sense that you need a bit less permission than the other two. I think you don't need the attach permission on ptrace. But the thing is that um, both the ptrace and the memory approach, the procfs, both of them allows you to write on read-only pages uh, because it's made for debugging and stuff like that. The syscall does not. So the exploit is quite a bit more complicated. If someone want to have fun, that's the fun path. This one requires to stop the process. Yeah, you stop the process, you find RSP, you write a rub chain on it, you trigger the rub chain does an mprotect, then After that, it send a stop to itself. It is stuck in it loop. After you restore the stack and make sure that the process doesn't break, and then you can go ahead and inject your backdoor. So that one is the hard one. This one is actually really easy to do, but a bit sketch because you're not stopping the process, so it can break stuff. And yeah, what I would recommend that's pretty interesting to do is the ptrace one. Yeah. Uh, I do have slides for the other two, but the one I'll focus on is the ptrace. Basically, there is a libc function that I think it's just called ptrace, and that you can call ptrace related function to it. So what you want is first you want to attach to the server process. Since you're in a Docker, the let's say the equivalent of the init, the like process one, is always the server itself. Well, the executable that the Docker runs. So in that case, that should always be one. But when testing on your machine, you can use a command with PID of to get that PID. Uh, the other thing that, yeah, that's kind of painful, but you can use the ptrace poke text and ptrace peek test to respectively write and read uh, memory regions. One thing that's kind of annoying when dealing with it is that you can always only uh, read and write on 8 byte 8 byte at a time, and it has to be aligned all the time. So if you want to do that, make helper function. It will be a lot less painful. You need to back up. Um, yeah, because of that, since you want to do some unaligned reads, sometimes you have to like read something, modify part of it, and write it back. There's that. And yeah, the two rights you really need to do is the right to write the hook and the right to put the rest of the payload in the code you don't care about, the FIPS one. And after you detach the process, or else everything will crash. And yeah, like I said, I'll go over quick. I already talked about the hook. Uh, if depending on how much you know about like assembly code, um, ret basically does pop RIP being the instruction pointer, and leave. If I recall correctly, it replaces RSP with RBP and pop the last RBP. So basically, that's what we call the not the prelude, but it's what you put at the end of the function to restore the state so you can continue where you left off before calling the function. So that's pretty useful because in the exploit code I'm providing, I do that at the end so I can return from the handler entirely, even though I'm not in the handler, which is kind of funny. But it allows us to resume execution without crashing anything. Yeah, that's the yeah, that's the backdoor key. What I said is that at that part, I'm in the shell code. I'm just checking, does the ID of the product of the review that I received from the handler, does that match a specific constant that I'm going to be using to trigger the backdoor? Break on that. If it doesn't, just continue normally so you don't break the application. If it does, jump to the full shell code. Full shell code, I explained it to you a bit earlier, but yeah, I I fork the process to have two versions of it so that the main process can continue to run and handle requests and everything. And the child does the socket reuse shellcode, which is the part that just binds binsh on the current connection. And also another thing is that you'd want the parent to put the file descriptor something like I think I put -1, but the reason you want to do that is because you don't want the parent to mess with the connection that now the child is using, and especially you don't want the parent to close the connection that you're using. Uh, oh boy, yeah, there's that. I I'll leave a bit more time just to like digest everything. Then I'll do that part, show the exploit in motion, and then we'll go to the defensive part. Again, I'm here from for questions. I know this can be a bit complicated, but I'm here for that. I'm sorry that I cannot leave you more time to it, but just that I want to let Ashley do leave him sometimes to do the defense. So I'll go over real quick the code that finds the file descriptor. That was, if you recall, it's that mess over here. So basically, when you enter the handler function, the function takes as an argument the gin context, gin being the web framework used. And you can assume from there that it probably contains somewhere in the chain the file descriptor of the connection because you need at some point to just, you know, respond to the request. So basically, what that does is that the first part that's over here is that yeah, that pointer is stored on the stack as a local variable. So I use the offset to actually dereference the pointer and get the context. And then, like I say on the slide over here, where is it? Over here, I just dive into the structure to try to find it. So yeah, I go to the gen context. That part, when I did it, I literally open up the Go source code for most of it, the Go runtime. Well, the standard library, but anyways, and just went and calculated offsite until I was able to get it right, and then verify with a debugger on the side to see if what I was doing made some kind of sense. If you want to do it yourself, one thing that's really important to note is that there are a lot of dynamic structures in that. Dynamic structures in Go, it's interfaces, but that's an object that you don't know the exact type at compile time. But you do have to store the information of what type it is at runtime. So when you're talking about like object-oriented code, polymorphism, all that stuff, those are dynamic variables. And how Go handles those is that basically when you have a dynamic object, the structure itself, which is funny enough, just a Go structure, is just two pointer. The first pointer points to a region in the code that basically some kind of manifest so that the runtime can know what actual type is there. And the second pointer points to the actual data. So when you find a pointer, when you find a dynamic structure, just know that you have to just say dereference the second pointer of that structure. And if you have a pointer to a dynamic object, you need to dereference the pointer, add a to what you get, and dereference that after that. So yeah, apart from that, I think all the big stuff. Like I said, I'm kind of sorry that I have to kind of rush it, but we have half an hour left and I haven't started defense. So if you have question, you can poke me on Discord after. I'll be hyped to help. But I'll just send a little like demo of how the attack would work. So basically, if I can write. So I yeah, let's say I start a server, do have a bunch of like logging and whatnot, and then I can call my injector target. Yeah, injector, like I said, you do have it. Um, you do have the complete code working in the repo, so you can just build it if you want to try it for yourself and see how it actually works. But yeah, I did implement the three of them, the three methods. So let's say I use the Pinterest one, which is the one I would recommend, and I tell him to attack the PID of its sandbox SVC review. Uh, yeah, that should. Oh yeah, and also like I said, you cannot just attach to any process in your system. On most systems, you need to run it as sudo. Yeah, I think it was in. Oh, yeah, I think I just called it server. No, I just like called it server. It's not the same executable name. How is that unexpected? Wait, don't know what. Oh, I think it's because there's two. Okay. Don't necessarily want to kill everything on my system that's called server. Would be a bit of a mistake, I think. Okay. So now with my logging, I know that the injection has run. So now the code I've injected has not run yet, but it's there in memory. And from there, I can go ahead and another script I made, it's shell.py. Basically, all it does is that it yeah, all it does is that it connects to the service via TCP or TLS if you're online, and send a GET request just raw like that. And after that, it just I don't know if you use Pound Tools, but it uses the interactive command, which is generally used just to give a handle to the user when you get a shell. So basically, I'm sending an HTTP connection, but just using like TCP libraries because I want to talk TCP after that. And when I run that, I get a shell. And I didn't break the app. The app is still fully working. I hope. Oh yeah, bye. That's online. But yeah, the app is still fully working, and I do have my shell. We're here. Who am I? I'm root. Well, not now because that's a local exploit. But yeah, that's pretty much it when it comes to the technical side. If you want to know exactly how, like practically to do the ptrace in the injector, I know it's really small, sorry about that. But in the injector, I have a file called procfs, a file called ptrace, and a file called syscall. Those are the three implementations of the methods you can use to inject. So for ptrace, I did the wrap attach process to add a bunch of handler, but yeah, I attach the process, I stop the process, I do a bit of pointer arithmetic, I read, yeah, I read a page for backup, I write my hook, I write my payload, I continue. So yeah, the meat is actually in the implementation I did to wrap the process. ProcFS is really simple. You open it as a file, you seek to where you want to go, you write, you seek to the other place you want to write, you write. It's literally file operation. It's funny, it works so well. And Syscall is more complicated, so that's an exercise to the reader if you want more of this. But this one is more complicated because you have to do rough chains and everything. So yeah. One thing to note is that unfortunately, the goal of this exercise was to find what hardening we could do to the platform. And the problem with that is that we did the job too well, so the exploit doesn't work anymore. But we put it in the best scenario we could, and you're able to inject the backdoor. The problem right now, and it's fixable, it just takes time, is that there is the load balancer that when it detects that your connection is in switch to TCP, will kill the connection because it only accepts HTTP. So it's possible to do a handler and proxy via HTTP2 to encapsulate a TCP connection, but we found that out yesterday, so I didn't have time to do it. So exercise for the reader if you want. But yeah, if you have any question, poke me on Discord. I know I went pretty quick for the offensive part, but a lot of content, and I know it's kind of hard. So yeah, hope you like my part. Uh, Honestly, I'd say it really depends on what you want to do. Um, if you want to, yeah, the best granular access, the one that you need the least access for, is the syscall method. But unfortunately, it's a lot harder to do because, like I said, you cannot just write on a read-only page like you can with the other two. So this is the one that requires the least permission. Um, Ptrace is interesting when you want to develop your exploit because you have access to debugging and everything. ProcFS is just really easy to write. So I probably recommend that. And also, I think that there's more detection about using actual ptrace than just writing to the ProcFS. I think. For detection, I'm pretty sure the best one is Syscall. Yeah. But yeah, if you want to read the code, it's interesting. There's a lot of good stuff for Syscall.
Share on my end. There's oh, so can you guys hear me? Um, so InfoStream is our new way of handling platform engineering, where we use the portal of InfoStream in order to generate pull requests that transform into manifests that transform into infrastructure. So you can talk to an an agent that help you with this type of request. Only allow team one members to access a certain route. Customers only authenticate via GCIP, not IAP. The agent in InfoStream to the portal that you guys see here. I think a lot of you guys got the access to the portal. The portal is our way of managing connections. For example, adding all the different users was done directly through the agent harness. So it's a series of agents helping any end user to make and generate pull requests that once get approved, start generating valid code references. So what did that generate in terms of reference? If we go check the different pull requests that it generated. So you could see, let's just try not to leak emails too much. This generated a specific pull request that was helped by the engine. And you get to see the members external that added to a certain team. That's done directly by the agent. So it helps people that are not technical still interact with the core engine. And then once those pull requests get approved, they get evaluated. You can also manage releases to different environments if need be. It's a workshop, so everything is on auto approve, so that we don't need to approve some of the releases. And the cool part that we did in InfoStream is we were previously on Terraform, and so we moved out of Terraform, and we're using our custom graph service. As opposed to Terraform, it's not single-threaded, so that allows us to run and execute 10 to 15 times faster than Terraform and have coherence at scale, because our objective is to manage and do vibe ops for companies in GCP. And if we go back to our presentation while it loads, we're going to give a few examples of what I mean. So one of the core things we try to do in InfoStream that is hard in infrastructure is to manage egresses strictly in every project. So for example, in the demo project with Phil, the allowed egresses was empty, was not API sendgrid.com and hooks.slack.com. That's an example. It would be a valid whitelist. And so any reverse shell you try to spawn or get that is not a GCP native link would fail. And so that's very, very annoying. That's what forced him to get a process duplication on the inbound link, because all outbound except Google native APIs were completely blocked. And that's how you get a lot of the security, is just a lot of networking and execution runtime discipline. After we're done with egress control, let's see how we make things happen on the ingress side. So we do leverage a lot of Google native features, such as identity aware proxy. We're using GCIP with tenant configurations. So for example, /API/product would use a GCIP-based authentication with a customer, and those engines would all be automatically be instantiated and configured by just this rule mapping being defined in InfoStream. And it routes to a deployment config, and the deployment config can be anything from a VM, a serverless, or Kubernetes. So the idea of simplification is the developer doesn't need to care or the infrastructure person doesn't need to care which one the developer picked. So that's why we do it this way. And we can also do on a certain path, say, hey, this endpoint is no longer under use by end users, but instead it's going to be used only by employees. And so you guys are all under employee management in InfoStream. Your Gmail accounts are considered for the portal and for the access as internal. So it means that you need that IAP cookie in order to get access. So it's like IAP is the Google virtual virtual access that requires employee-based tokens and Google identities. And so that's what we've deployed. And that's why you guys can't access each other's references. So team 21 can only access team 21, and team 20 can only access team 20, and no one else. And this was, for us, extremely hard to do. I know you guys have been working with authentication and authorization at scale. We don't just do it per host, we do it per route. There's even more advanced config using authorization gateways, but that's not usually done by the big public. And why is container hardening matters? In this case, the backend runs on serverless, not just VM and Kubernetes. We're using the new gvisor sandboxes from version 1 or version 2. And basically, you can run with virtual root in the micro VM in the serverless. But in that micro VM, even if it drop Linux capabilities, you can still move around depending on the config. You can still read keys, get secrets, get some form of persistence, exfiltrate to the network services that cloud run normally has access, and then do kernel attacks that try to bypass the sandbox isolation if you have 0Ds. And our point in next is you should be at least dropping the config in that container itself. So when you're in the container, you can pass a proper Dockerfile config so that end user in that container runs as a user, no longer as a high privilege. It doesn't try to run in the VM with 0. And so that's our recommendation. In the case of a cloud run, you would need to enable. So by default, it drops all capabilities. But if you want to prevent lateral movement and out of normal operations, you're much better off using secure Docker files. And so that's the layer of responsibility that you usually have to manage. So Gen 1 and Gen 2 are the configs of a serverless. You can do things such as a non-root user, no shell, only exposing minimal packages, read-only binary that helps reduce your supply chain vulnerabilities. What happens at the container level is done by partly Docker and your configs. And then you have a sandbox provided by your serverless, in this case, Google for the serverless Cloud Run. And then you have the network isolation, kind of a higher level that's controlled by InfoStream. And an example of before and after a hardened Dockerfile config. So if you're like a lot of developers, they just do Ubuntu latest. They don't even pin it. Any new supply chain vulnerabilities gets applied every time it's pulled. It loads and updates the upgrade of a certificates, and adds JQ and bash, uses root as a work directory, and copies the distro of your binaries, adds a few environment variables, and then runs the CMD. The hardened version is usually using a pinned version, adding, and then using the different permissions required, add the user ID, group ID, and then at least run the system as non-root. So those are the good practices that limit the attack surface by quite a bit. And if you're doing it like we try to be, which is the maximum level security, you would instead run from scratch, copy the certs and the zone info, drop as non-root, and then run those run container as scratch. What does it mean in practice between the 3 tiers? If you run it as unhardened, you end up with an image size of around 180 megabytes. If you run it with a semi-hardened version with Ubuntu, it runs down to 90 megabytes. You have to add the base OS packages that can have vulnerabilities or not for local privilege escalation. You have access to shells or not. In the scratch, there's no shell whatsoever, which makes the exploitation even more complex. The user in the different configs runs either as UID 0 or the one that we've defined. And the binaries, there are few present in unhardened. They're stripped for the SUID for privesc, and they cannot exist in Scratch because you're only copying the binary you're targeting. And the CVE surface makes it so that if you're in Scratch, it's a lot easier to maintain. We got updates or upgrades or vulnerabilities maybe once per year due to 0-day, not 0-day, but large CVEs. Otherwise, you don't care. There's only your applicative binaries in the containers. And the Docker execs, etc., are much harder as well. And the Linux capability. So this one is reusable. So that part um, it I advise. Well, we think that's the knowledge that's really useful. People kind of often forget that they can add Linux capabilities. So the capnet raw is and capt net admin are capnet raw and sysadmin. So the first and second are usually needed if you have Istio or service meshing. If you're using the new ambient mesh, you don't no longer need that, but you will tend to see those first two. The capdac override are sometimes used, and the set UID causes escalation problems, but they can seen sometimes in older school VM configs. And the CSP trace is the privilege required by Phil to do his attack. And uh, cap chown is directly used for direct escalation. So that one, if you're not in Scratch, it's rarer to use, but you can see it in a few VM configs. It's just if you guys are using VMs or Kubernetes, you have to be aware of those capabilities. They're not just used for development; they can generate significant risk for your Kubernetes clusters, in particular at the node level. And finally, um, the hardening, like we mentioned in the cloud, if you're trying to do it in a fully automated fashion, is hard because you have to control in a very disciplined fashion release management. You have to manage networking, internal and egress. You have to manage the packages. You have to manage the databases. And usually that's much harder to do. And that's one of the reasons why we built our version of platform engineering, and to which we added agentic capabilities to make it simpler and more approachable. And just to close on this topic, okay. So people ask us, yeah, you guys did your own manifest structures and your own platform engineering. How much more complex or less complex than Kubernetes is it? Because Kubernetes looks very complex to me. So if we go through a few of them, for example, on the database, we specify things such as this file that gets created by the agent and then represents the reality of the infrastructure. In this case, we specify an AlloyDB with CPU count and cluster size. That's what we mean by intent. And then we have the different tables and ownership and the extensions per table. And so as we can see, the ownership of the different tables was done for the different teams. So each team, even though we're running serverless, had their own table ownership. So they couldn't contaminate each other on the table side, even if you guys could move laterally. And so we've defined the 25 teams and the max number of connections and the config of backup. We've isolated a deployment config. So for each team, again, we have multiple services that were done for category and review. And when we look at the depth of a config, it's again not that big. We only specify the environment variables that are done and deduced correctly for serverless or Kubernetes as well, not just VMs. And we specify the other parameters that are necessary for this config, and then we do automatic file mounts if necessary. And so that's what we mean by simpler configs. And as you can see, on purpose, we try to avoid a lot of security configs outside what we absolutely need from end users. Like specify the prefixes, the type of authentication, the route. And in this case, we had quite a few services planned, but they're not exploitable. They were done in case we wanted to have lateral movement and show that in the exercise. And we had redirects, path matches, but most, as you can see, all endpoints are internal. So that's why every team could only access their own resources. And on my end, it's mostly it. We can also do VM configs. That's what we ended up doing for Phil's to attempt a specific VM config in case the cloud runs did work or were hardened. So we tried using Ubuntu VMs and disabled the mesh, added a configuration with a source base that we maintain, and then we specify the container tags, some of the database secrets if need be. Those secrets are referenced in GCP secrets. And then we have references such as Redis, but that's the entire VM config. And yeah, If you guys are looking or interested in this way of handling platform engineering, we're still in early access in private preview. So if you guys want to register and play around with it and for a month or two, we have it for free for now. And we have more information on infostream.io/early access. Thank you. Yeah. Yeah. So the InfoStream runs in the client. So it's not a SaaS. The SaaS is just for instantiation. And then the images are GCP auto-upgraded images. And so the base image of the hosts of the VMs get constantly updated. Like the cars get updated twice a day. And what we're deploying on the VM is just a container. So all the workloads, whether they run on Kubernetes, VM, or Cloud Run, are all containers. So the core OS gets updated by the cloud provider. We don't do the VM updates. So that's a core feature of GCP, and so you get that automatically. Basically, there's no golden image. What you're doing is a rolling version of base host image with Google Cloud. Yeah. So in this case, you're taking the rolling base version of GCP. And we're not doing that effort. You can define a custom image, but then you have to do the QA yourself of injecting agents, injecting custom versions. But here this one is the base version of Ubuntu 24.04, and Google is updating it for you. And on a daily or weekly basis for Ubuntu, but the cause, the one we're using, that's much harder to attack, is on a daily basis, where the memory in TMPFS is mounted as read-only and non-executable. So it makes a lot of attack vectors a lot harder.
Yeah, that's something that I kind of bash my head against. What we did find with COS is that in that context, you have a scratch image, and so you have nothing installed except the actual process that's running, and with the tempfs that's not executable. I literally couldn't find a way to break out of the process itself. I cannot drop script and execute them because there is no scripting language anywhere, and I cannot upload and execute my executable. So yeah, no execute on the tempfs and a read-only file system. Those two together, that's really strong. Oh, yeah, just wanted to say another thing. If some people want to keep their instance up for the rest of the day, just ping us because we will, for cost reason, disable all the ones that do not explicitly ask for it.
Thank you. So you can do so on Discord, message me or Philip in order to keep them up for the rest of the day.
And thank you for coming.